Welcome back in Physics ki Drishti. Today we will learn B.Tech Engineering Physics important question. But these question carries 6 marks. So 6 marks important question, and in this video we will cover first unit, that name is laser and optics fiber. Okay, so let's start. Our first important question is what? Mention a one solid state laser, draw the diagram and show its construction. Mention its working mechanism with proper energy level diagram. State one disadvantage. See, they are asking one solid state laser. So everyone know one solid state laser, that means what? Ruby laser. They are asking draw the diagram, that means diagram is required. Then you have to write down the working with its energy level diagram and some disadvantage. So how to write in your examinations? First of all, you have to write down solid state laser, that means ruby laser, and then draw its diagram. So this is the complex diagram, but you can draw a simple diagram, like first of all draw the active medium. This is the active medium, that name is what? That name is ruby rod. Okay, so just show, okay, this is the ruby rod. After that, pumping mechanism, everyone know this tube light, that is a xenon tube light, and connect with the power supply. So this is your high intensity flash lamp. And third thing which is required, that is what? This glass, first glass and second glass. This is the 100% reflective mirror, and this is 95% reflective mirror. And just connect with the switch and just draw a outside box. This is your diagram of the ruby laser. Everyone know whenever this lights on, what happen? Pumping mechanism provided, and every time due to the multiple reflection, we got the laser light. This is the laser beam. Okay, now explain its construction. So start with some description. Ruby laser is the first laser invented in 1960 by T. Myman. Ruby laser, a ruby rod, is a ruby crystal, that name is Al2O3, and doped with which ion? Chromium ion. That percentage is what? 0.05 percentage weight of chromium plus 3 ion. And write down some aluminum and oxygen atoms are inert in that. Second thing, you have to write down ruby laser in the form of cylindrical rod, that size is 2 to 30 centimeter in length and 0.5 to 2 centimeter in a diameter. Then you have to write down, we have a two different types of mirror, 100% reflection mirror, while the other silvered, to give a 10% transmission and 90% reflection. And the third thing, we are using the pumping mechanism, that name is what? That name is helical flash tube or xenon flash tube. Okay, so this is all about its construction. Now draw the working diagram. This is the energy level diagram, and explain its working. So first of all, draw this E1 energy level, that is your ground level. Then this is your E2 energy level, that is your metastable energy level. And this is your E3, that is the highest energy level, that means excited state. Got the idea? Now use the one external light pumping transmission. So what happened here? Whatever electron we have, that absorb all these radiation and going to the excited state. Now electron is here. Now what happened? Automatically spontaneous emission occurs, that is radiation less transitions, and that electrons comes to the E2 state. And here stimulated emission occurs, and this electrons comes to the ground state. So during this process, one external photon and one another photon which is emitted, that is what? That is considered as a laser light. Okay, or laser transaction. That color is what? Little bit pinkish or little bit pink. That's why, or that name is what? Rubies. Got the idea? So this is your energy level diagram. In this diagram you have to write, okay, this is the three level pumping scheme, and chromium ions are the active centers in this particular thing. And then just explain whatever we are learning from the energy level diagram. From the normal state, chromium ions are going to ground state, even to excited state, E3. Then what happened in the excited state? It has a very small time, 10 to power minus 9. So what happened automatically, the chromium excited ion which rapidly lose the energy and reach to the E2 level. And then what happens? Stimulated emission happens, and from ET2 transition occurs in E1 level. And during this process, whatever we get, that is what? That is your laser light. That wavelength is 6943 angstrom. Very simple or not? So this is all about the working mechanism, and write down the one disadvantage. So we already know that main disadvantage is ruby laser is a pulsed laser in form, and the second disadvantage is the large pumping is required. So these two are the disadvantage. If you are able to write these things, you got the 6 out of 6 marks in your end semester paper. So this is our first question which carries 6 marks. Now second question is define the optical fiber. First of all, they are asking the definition of optical fiber, and then derive the expression of numerical aperture. Expression, you have to derive the expression and then explain the structure of optical fiber with the proper diagram. So let's start first what is our first question? Define it. So an optical fiber is a cylindrical waveguide made a transparent dielectric, that means glass or clear plastic, which guides light waves along its length by total internal reflection. This is the principle of optical fiber, total internal reflection, and it is a thin as a human hair. Its size is 70 micrometer. Micro, that means how much? 10 to power minus 6 meter. Got the idea? Now our second question, derive the expression of numerical aperture. For that you have to draw this diagram. Your n0 is a medium, the incidence angle is theta 1, then this angle is theta 2, this angle is theta 3. Everyone know inside part is core and second part is cladding. Now apply the sales law. N1 N0 sin theta 1 is equal to N1 sin theta 2, and everyone knows sin theta 2. So can we write sin theta is equal to sin 90 minus theta, and sin 90 minus theta is equal to what? Cos theta. So just replace N0 sin theta 1 is equal to N1 cos theta 3. And when total internal reflection happens, when your incidence angle which is greater than critical angle, so you can compare, okay, your theta 3 which is equal to theta c. So we got equation number 2. N0 value is 1. So how to write sin theta c? N2 by N1. So can we write N0 sin theta 1 sin theta a is equal to N1 under root 1 minus sin square theta is equal to cos square theta. So you can write 1 minus N2 by N1 square. You can put this value. So what we get? N1 square minus N2 square. So this is your final formula. Numerical aperture is equal to N1 square minus N2 square. Your equation is derived. And next thing they are asking in this question, what? Structure of optical fiber cable. So your first inside part is core, second part is cladding, and the third part is jacket protection. So you have to write one or two line for each. First, core. What is core? Which is made by silica or germanium. The innermost cylindrical region in the light guiding region known as a core, and its diameter is approximately 8.5 to 62.5 micrometer. Your second part is cladding. So core is surrounded by its a coaxial middle region having a diameter of the order of 1 to 5 micrometer. That name is what? Cladding. And everyone know the core refractive index N1, which is always greater than the N2. N2 is cladding refractive index. And the third last sheet, outer sheet. So outer sheet is the outermost protective layer, is called a buffer coating or sheet. It is a plastic coating given to the cladding for extra protection or physical or environmental protection for the fiber, and its size nearly 250 to 900 micrometer. So your explanation of structure is done. So up to this you got 6 out of 6 marks. So our second question is done. Now next important question, third important question. See, here we have a two different question, but both answer is same. The language is totally different. In the first, they are asking explain the detail in the interaction of EM radiation with matter with proper energy diagram. That means what they are asking explain the interaction of EM radiation with matter. So whenever electromagnetic radiation and matter interaction happens, always three things happen. That is what stimulated absorption, spontaneous emission, and stimulated emission. And just check the second question. Explain the stimulated absorption, spontaneous emission, and stimulated emission. See, this is the direct question, this is the indirect question. But both answer is same. What is the answer? Let's try to write. Einstein explained the interaction of electromagnetic radiation with matter with the help of three processes. First process is stimulated absorption, second is spontaneous emission, third is stimulated emission. And now explain each. So first one is stimulated absorption. What mean by stimulated? So always remember the stimulated, that means some external factor is there. An external factor, suppose this is your E1 and this is your E2, whenever external wave is there, this electron will absorb this energy and going to the excited state. This process name is what? Stimulated absorption. So how to write? Consider an atom initially in a lower energy states. A photon of energy, when incident on the atom, it is absorbed by the atom. That means this electron absorb this energy, and on absorbing the energy, the atom transits to its higher energy state. This phenomena name is what? Stimulated absorption. Got the idea? So this is the same thing. And the rate of stimulated absorption is what? R1 is equal to B12 rho V and N1. N1, that means how many numbers is present here, that is N1. Rho V, that means whatever external uh, light density, rho V. And B12 is what? B12 is your Einstein coefficient of stimulated absorption. Got the idea? Second thing is spontaneous emission. Why the figure is not here? Okay, no problem. Spontaneous emission I already put here, but it is not visible. We will try to draw it. Okay. The lifetime of upper energy levels are very short. That means what? That means here we have one excited state, that is E2, and here we have a E1. This is the energy level. Sorry. This is the energy level is E1. Okay. The energy level is empty. Can I rub it? Yeah. Clear? This energy level is E1. So that lifetime is very short. So consider an atom initially in E2 state, that means the electron is here and it can come down the ground state E1 emitting a photon its own after 10 to power 8 second without any external agent. So what happened after some time? This is the before position, and after that what happened? It will immediately left the excited state and come to the ground state, and it will emit some photon. This is your photon, that means light. So automatically this process happen without any external agent, and that process called what? Spontaneous emission. Got the idea? And the rate of spontaneous emission is A21 and 2 N2, that means number of this energy levels, and how many number of electrons are present is there, and A21 is what? Einstein coefficient of spontaneous emission. Okay. And third, okay, the diagram is here. Okay, I forgot because of the animation. See, this is the first process, and immediately these electrons will comes down and the photon emission is there. This is the after emission process. And next thing, stimulated emission. So same thing, the first electron is here, but whenever external photon is here, what happen? Every time due to this external interference stimulate, this photon is stimulated for the laser action, and what happened? This electrons come back to the ground state. This is the energy which is emitted, and again this photon is coherent with this another photon. So we got a coherent light, and this is your laser light. Got the idea or not? So this is all about the stimulated emission, and the rate of stimulated emission is B21 rho v n2, and B21 is a what? Coefficient of stimulated emission. So these three processes are very simple. Just write down these three process. Simple diagram is a must. If you are able to draw the diagram, then half of the marks, 3 marks only for the diagram and 3 marks for the explanation. You got 6 out of 6. Next question. Next question is, derive the relation between Einstein coefficient of stimulated absorption, spontaneous emission, and stimulated emission. This is another very important question, and you have to write from this. Let's consider a independent atoms exit only two levels, 1 and 2, energy E1 and E2 level, and then apply the Maxwell-Boltzmann statistics. N2 is equal to N1 exponentially E2 minus E1 by kT, where K is a Boltzmann constant, T is a temperature. Now we already know the rate of stimulated absorption is this one, rate of spontaneous emission is this one, rate of stimulated emission is this one. So you have to directly write down this. No need to explain this. Just write down this and then try to derive or try to explain the Einstein coefficient or derive it. How to derive it? First of all, write down under the thermal equilibrium, the number of atoms absorbing the photon per second is equal to number of atoms emitting photon per second. And then what happened? Whatever absorption rate R1, which is equal to R2 plus R3, because these three, R2 and R3, R2 is spontaneous and second one is stimulated. So absorption is equal to emission. So directly write down R1 value, this is your R2 value, and this is your R3 value. And now try to find out rho v. So just take this minus this and take common as a rho v. So rho v is equal to this. Okay, and now dividing above equation by B21 into N2. So try to divide it. So here B21 N2, so N2 N2 cancel out. So what is remaining? A21 by B21. So this is E21 by B21. Now divide it again, divided by B21 N2, B21 N2. So this is the thing, B21 N2, B21 N2, so cancel out. So what we get? We get equation number 4. Got the idea? And now we already know, according to Maxwell-Boltzmann, N1 by N2 is equal to this, and try to simplify it, E1 by KT, E2 by KT. So can we cancel KT, KT, and what become? Sorry, KT is a common and E2 minus E1. So what we get? H nu by KT. So N1 by N2 is equal to what? E raised to H nu divided by KT. Okay, and A2 and B, A21 divided by B21 according to the Planck's, what Planck's energy, its value is 8 pi nu cube, 8 pi h nu cube divided by C cube. So you can directly write down this value accordingly. Here B21 by divided by B12, both are cancel out. Why? Because both rate is same. Okay, so directly cancel out whatever remaining thing. This is the remaining thing. So what we get? We get our equation number 6, and you can directly write down, okay, this is your the first equation and this is your second equation. So what we get? This is your first equation, this is your second equation, and these relations are known as a Einstein relation. Up to this, if you want to write down two condition, it's very good. Otherwise, up to 6, you got 6 out of 6 marks. These are the relation known as a Einstein coefficient relation. Got the idea? And the last question from this unit, explain the component of laser. What is the role of optical resonator? Optical resonator, that means what? Optical resonator, that means these two meters. Okay, so what are the components? So there are the 3 components. First thing is active medium or gain medium, second thing is pumping scheme, and the third thing is optical cavity resonator. Okay, First thing, active medium. So this is the medium, that name is laser active medium or gain medium. Whatever provided external energy, that is pumping, either it is through the battery or through the chemical or through the light, whatever. And third thing, optical cavity resonator, that means these two mirrors, one is 100% reflective and second one is partially reflected. So these three are the components, and explain each and every one. So let's start. First one. First one is active medium. So the fundamental component of laser is a material medium which is known as a active medium or gain medium. This active medium can be a solid, liquid or gaseous in a nature. After the invention of ruby laser, solid state laser, other active medium such as a glasses, plastics, liquids, gases and even plasma were used. The main thing is this: in active medium, only a small fraction of atoms are responsible for a light amplification known as a active centers. This is the main point, and an active medium should possess good mechanical, thermal, optical properties as well as transparency to stimulated radiation of laser output. So this is all about active medium. Your second component is pumping technology. So to produce the population inversion, the method of raising the atoms from lower energy to higher energy, it's called what? Pumping. And there are most commonly pumping method is optical, electrical or chemical. You already know, whenever we discuss ruby laser or Nd:YAG laser, majorly used in solid state laser, that is optical pumping. You can light or xenon flashlight, that kind of things. Okay, that is the optical pumping. The example is this. Second thing is electrical pumping. Electrical discharge pumping is used in a gas laser like HENE laser or CO2 laser. So this is all about the pumping scheme. And the third thing is optical resonator. So what is optical resonator? Two mirror, M2 and M1, one which is 100% reflective and second one which is 90 or 95% reflected, whatever percentage we have. So a pair of a plane parallel mirror set on optical axis which defines the direction of laser outputs. One is perfectly reflecting mirror and other one which is surface is partially reflecting mirror. In this resonate cavity, the intensity of photon is raised tremendously through the stimulated emission of process amplification of stimulated emission. And next they are asking, see in this explanation it is answer is already there. Due to this mirror, the intensity is very high because of amplification process is done. And at the end they are asking what is the role of optical resonator. So this is the main role of optical resonator for a high amplification and amplification of stimulated photons. Every time multiple times reflection happens, and due to multiple time reflection, what happens? Amplification of photon is there, and that's why we got a laser emission. This is the role of optical resonator. Got the idea? So up to this you got 6 out of 6 marks in this particular question. So these 5 questions are very important from the laser and optics fiber units. And thank you very much to all to provide this type of support to our channel Physics Ki Drishti. And in next video we will discuss our unit number 2, modern physics, important question. Modern physics, very important question. So subscribe, like, share and comment below. Thank you for your support. Thank you everyone.